Welcome to GATE CSE. We'll solve few problems on special matrices. So given this matrix, which of the statements is true? P is idempotent, P is orthogonal, eigenvalues of P are 0 and 1 only, determinant of P equal to 0. So idempotent means P square should be equal to P. So we find out 1 0 0 0 0 0 0 0 1 into 1 0 0 0 0 0 0 0 1. So this resultant will be 1 0 0. This is 1 0 0 will be 0 0 and 0. This will be 0 0 and the last is 1. So this is equal to P. So therefore it is idempotent. Is it orthogonal? Orthogonal means you have to check Q into Qt into Q is equal to I. Okay, P into P transform into P is equal to I. Otherwise, you can use the shortcut from the definition of vectors. So check the square root of the each column value should be 1. So what I am saying is, if I take this column 1, C1, so the length of C1, we write it like this, is square root of all the elements C1 plus square C1, C21 square plus C1 square. That is 1 square plus 0 plus 0, that is 1. Similarly for C2 equal to 0. So this is not orthogonal. All columns should be 1. This is not true. Eigenvalues of P are 0 and 1. This again in the next problem I will tell the full formula. So two conditions you have to check for orthogonality. You wait for the next problem, I will explain. Eigenvalues of P are 0 and 1 only. Okay. If you find the eigenvalues, I will get 1 minus lambda square into minus lambda equal to 0. So lambda will be 0 or 1. This is correct. Determinant of P equal to 0. Yes, because one of the eigenvalue is 0. Next. This should have been MSQ. Next. Identify all orthogonal matrices. How will you check the orthogonal matrix? Any column length. See, the standard method is you take this Qt into Q is equal to I, but it takes a lot of time. So you check for each column. Length of each column is equal to square root of C1 j square plus C2 j square plus so on. Okay, it should be equal to 1 for all the columns, for all j. And the dot product is, the length should be 1. That is the first condition. And the dot product between, this is the first condition, should be applied for all the columns. All the columns, the length should be 1. This is how we calculate the length. Dot product between any two columns. Check all the columns to be equal to 0. I'll show you the example here. First, there are three columns C1, C2, C3. So the length of C1 is equal to square root of 0 square plus 1 square plus 0 square. That is 1. This column I am taking, first column. Now take the second column. All columns should have length as 1. This is 0 square plus 0 square plus 1 square is 1. Then you have C3 is equal to 1 square plus 0 square plus 0 square is equal to 1. So this condition holds. Now second condition also you have to check. Both the condition holds only, then you can say it is a orthogonal matrix. So dot product means what? For between any two columns, please multiply those values, okay, in the rows and then add them. So if I take dot product of C1 into C2, okay, dot product of C1 into C2 is nothing but you multiply these two, 0 into 0 plus 1 into 0 plus 0 into 1. This will be 0. Then so to check for all, C2 into C3 dot product. So 0 into 1 plus 0 into 0 plus 1 into 0 is 0. Then the last pair is C3, C2. Again it is 1 into 0 plus 0 into 1 plus 0 into 0. So we satisfy second also. So all dot products is 0. Therefore this matrix is orthogonal. Similarly, we check for all these three. So we'll get, except C, we'll get all these as true. Phi C, if you see here, if I take this column length, it will be square root of 0 square plus 4 plus 0, that is 2, is not equal to 1. Therefore, it's not orthogonal. Next, what are the eigenvalues of this idempotent matrix? Idempotent matrix eigenvalues will be 0 or 1. So this is 1 minus lambda, okay, minus lambda and 1 minus lambda. So this is 1 minus lambda square into minus lambda equal to 0. So equate it. So lambda will be 0 or lambda equal to 1. So 0 or 1. Let Q be a 3 cross 3 orthogonal matrix. Already they are declaring it as orthogonal. In which of the following is always true? So Q transform into Q is equal to I. So therefore Q inverse will be Q transform. So this is true. Determinant of Q is equal to 0. So determinant of any orthogonal matrix is always plus or minus 1, that is mod of 1, we write it, or plus or minus 1. So this is not true. Q is symmetric. So Q need not be symmetric in the case of orthogonal matrix. For normal matrix, it is symmetric. The length of vectors Qx will be equal to x for any vector x. That is the definition of orthogonal matrix. Next, let P be a projection matrix. Which of the following statements are true? It is idempotent. True. Eigenvalues are 0 or 1. P is always invertible. Since eigenvalue is 0, it may not be invertible always. I minus P is also a projection matrix. Okay. Consider a block diagonal matrix. So this is a diagonal matrix and B and C are the blocks here, not the elements. Then which of the following statement is true? Determinant of the matrix A will be determinant of block B into determinant of block C into. So this is true. This is false. You can also find inverse A inverse as B inverse into C inverse. If and only if B and C are invertible, that means determinant of block B and block C is not equal to 0. So already I mentioned it's invertible means they are not 0. Determinants are not 0. Eigenvalues of A are union of eigenvalues of B and C. This is also true. So this is one block, you find the eigenvalues of this block, lambda 1 or lambda 2. Then here you say lambda 3, lambda 4. For the entire matrix, it will be lambda 1, 2, 3, 4. When you split this, it becomes a big matrix, a diagonal matrix itself. Block B, say, has some 4 elements. 4 elements comes here. Again, 4 elements comes here for C. So it is again the same diagonal we get. Let A be a symmetric idempotent matrix. Which of the following are true? A square equal to A. So for idempotent, it is true always. Then A equal to A transpose, because for a symmetric matrix, it is true. Then rank of A equal to trace of A. Yes, for symmetric matrix, idempotent, rank of A is equal to trace of A. Then eigenvalues of A can be negative. Now, eigenvalues can be 0 or 1 only, so it cannot be negative. Given this matrix, which of the following statement is correct? So, is it a idempotent matrix? So, find out P square equal to P. So, if I square this, I will get 1 by 9 into 3, 3, 3. So this is nothing but equal to my P only. Hence, it is idempotent. P is a projection matrix. Yes, P is a projection matrix because P square equal to P. P is orthogonal. So if you take the length of this columns, so 1 square plus 1 is root 3 by 3. is not equal to 1, hence this is not orthogonal. Rank of P is equal to 1. Yes. If I convert it to row echelon form, what I will get? So these two rows will become 0, 1 minus 1, 1 minus 1, right? So only one row will be linearly independent. So rank will be 1. Which of the following properties are true for an orthogonal matrix? Q transform into Q equal to I. Q inverse equal to Qt. Then eigenvalues satisfy lambda equal to 1. This is also true. Q must be diagonalizable. So here Q is, remember this, Q is diagonalizable only when Q is belongs to complex numbers. Q belongs to real domain, it may not be diagonalizable. Okay, so this is not true. So if they have mentioned C complex domain, then fine. They are not mentioned, then in real domain it's not possible. So they are asked in real domain question. Next, find the rank of the projection matrix. So the projection matrix rank is nothing but will be only one linearly independent row. So that the rank is always 1. Okay. So with this video, we complete the basic concepts of matrices and linear algebra with its properties, determinants, rank, okay, small concepts of spaces, null space, rank nullity theorem, systems of linear equations, decompositions, Gauss eliminations, and all those things we have learned. So from the next video, we will solve some of the previous year GATE questions. Okay, and then we'll conclude this subject. Thank you for watching. We'll continue in the next video. Please like, subscribe, and share.